Hello. So in this lecture 4.5, we'll be covering some applications of the concepts covered in lecture 4. So that would mean that we would be using IVPs or initial value problems in real life scenarios. So for our first example, let's say we have a bucket of water and it has 300 gallons in it right now, and it has 8 pounds of salt inside, where A is a function of t and it's constantly changing. So let's say that we have water that's flowing at a constant rate of r gallons per minute, and that water has a salt concentration or salinity concentration of, I don't know, 3 pounds per gallon. So salt concentration. I'm not going to write the full word. Now, let's say that we have water leaving this bucket at the same rate, so also leaving at r gallons per minute. The question is, how do we find a function a of t such that it models the amount of salt in the water at all times t? Well, to figure this out, we can find a differential equation for the concentration, or sorry, not concentration, the amount of salt that's in the water. So dA dt. So we know that, first of all, A equals, so then the total salt is equal to the concentration. So our concentration would be, I'll just write concentration. And I'll just make sure A is amount of salt in pounds. R equals rate of water flow. Just so there's no confusion. So A is equal to concentration times volume. So therefore dA dt equals concentration times d volume dt. So that would equal concentration times r. So now we just need to figure out what this concentration is. So it's quite easy to figure out what the rate of salt flowing in is. It's just going to be concentration times r. So the concentration of salt going in is just 3, because it's just 3 pounds over gallons. So then we just need to know that 3r is going to be what flows in. So this is flow in, salt flow in. Now we need to know what the salt flow out is. So to do that, we need to know what concentration is. So to find concentration, we know that we have A of t pounds at all times. So right now we have A of t pounds of salt in here, and we have a volume of 300 gallons. So this is going to be our concentration here, and then we can just multiply by r, because that's the volume flow out. So then we would get AR over 300. So our differential equation would be AR, so dA dt equals 3R minus AR over 300. So now I can just erase all of this so I can actually solve the differential equation. So we can bring this to the left side, so we now have AR over 300 equals 3R. And now this becomes something that we can solve using integrating factor. So we have r over 300, which is a constant, as our p of t. So p of t equals r over 300. Q of t is 3r, whatever is on the right side. So then u of t is just the integral of r over 300, but since it's a constant, we just add t. So now we can generate a solution by just plugging into the formula. So we have a of t is equal to 1 over u of t, so 1 over e to the r 300 times integral of 3r times e to the rt 300 dt. So e to the negative rt 300 times integral. And now this is an annoying u substitution because of all the added variables. So we can just say that u is equal to rt over 300. So then du is equal to r over 300 dt, which would mean dt is equal to 300 over r du. So then we would end up getting the integral of 900 e to the u du. So then that would be e to the negative rt over 300 e to the u, but then I'll just substitute this right back in. So we'll have 900 e to the rt over 300 plus c. Okay, so what is c? Well, wait, hold on, let me just do this algebra first. So it's 900 plus ce to the negative rt over 300. Now, we can use initial values if I just assign some initial values right here. So I think I can just erase this now. So let's say our initial value. So when t is at 0, there's initially, I don't know, 100 pounds of salt in here right now. So then how would we find a specific solution for this general solution? Well, we can just plug 0 in. So we have 900, or a of 0 equals 100 equals 900 plus c e to the negative r 0 over 100. So then that would be 900 plus c, which would mean c is equal to negative 800. Therefore, our a of t would equal 900 minus 800 e to the negative rt over 300. Well, remember, r was never specified, it's just a constant, so we could just keep it there. There's no initial values for the r, just for the c. Okay, anyways, I hope you liked this video, and I'll see you in the next lecture.